What's up, team? This is Ro, your best friend at JMSB. So here I was asked a question for COMM 220, analysis of markets. Let's have a look. Hey Ro, can you cover an example involving economic rent? The truth is, I really like this question, and that's simply because I'm pretty confident that it's going to show up on your midterm this Sunday. And so the best way to tackle this concept is perhaps by trying out an example. So I've created an example for you guys. Let's have a look. It's the example of the moment. Here it says, suppose that the demand and supply for Grade Savers tutors are given by the following expressions. So WD is 100 minus LD, WS is 20 for LS less than or equal to 10, but WS is 10 plus 2LS for W greater than or equal to 20. In required 1, it simply says to find the equilibrium quantity and wage rate in this labor market. So the way that we're going to do that is simply by equating the labor demand curve to the labor supply curve. So the idea is to equate WD to WS. I would recommend to start this process off with the second supply curve. And if you end up with a wage rate that is less than 20, then you would repeat those steps with the first supply curve. So equating WD to WS, we are able to calculate the equilibrium labor hours. And once we have done that, the idea is simply to plug back the labor hours either into demand or into supply and to calculate the equilibrium wage rate. So this part should be pretty straightforward for most of us. It's just the act of finding equilibrium. And if you work that out, you should be getting an answer of 30 for the labor hours and 70 for the wage rate. Let's have a look at required 2. Here it says, illustrate the market equilibrium on a graph. So we're going to set up a market diagram where we're going to illustrate the demand and supply for this labor market. On the x-axis, I would recommend to put the labor quantity, and on the y-axis, we're going to put the wage rate. Our demand curve is going to be a typical downward sloping demand curve with a y-intercept of 100 and an x-intercept also of 100. And that's simply because we are offered an inverse demand curve where wage is isolated on one side, and whenever that happens, the constant is the y-intercept. So this 100 is the y-intercept of our demand line. Moreover, the x-intercept is simply 100 divided by 1, and so that's also 100. The supply curve is in 2 parts. For labor hours less than 10, we have a wage rate of 20, so the supply curve is going to be horizontal up until labor hours of 10. And after that, we've got this second supply curve that we are hoping to graph. And so the supply curve is essentially going to be kinked. It's going to be horizontal at 20 up until labor hours of 10. Beyond that, it's going to be upward sloping, and that's simply because we're graphing the second supply line. Once we've done that, we can also illustrate the equilibrium quantity and wage in this labor market. And so, as we can tell, the equilibrium quantity is 30 and the wage rate is 70. Let's have a look at required 3. So here it says, calculate the value of economic rent. What's pretty chill to understand is that economic rent is essentially the same as producer surplus, but in the labor market. So it is the area that is bounded by the supply line, the price line, and by the quantity. To be more specific, it is the area that is above the supply, below the wage rate, and on the left of quantity. To illustrate this area on our graph, it's essentially the area that is found right here. This is called economic rent. In order to calculate the economic rent, we're essentially going to break this area down into 2 familiar shapes, perhaps a rectangle and a triangle. And then we can simply add up those 2 areas individually to determine the total value of economic rent. I remind you that whenever you're finding the area of a rectangle, it's simply base times height. However, when you're finding the area of a triangle, it is base times height divided by 2, simply because triangles are half rectangles. And so if we were to evaluate that, we can see that the height of both shapes is 70 minus 20. The base for the rectangle is from 0 all the way to 10, and so 70 minus 20 times 10 is how you'd find the area of the rectangle. The triangle is 70 minus 20 multiplied by 30 less 10. And because this is a triangle, we are dividing by 2. If we work that out, in my opinion, you're going to get 500 plus 500, perhaps 1,000. So hopefully this explanation helped, and if it did, make sure you're tagging your friends that are taking COMM 220. As I explained to you guys earlier, I'm pretty confident that this concept is going to show up on your midterm this Sunday, so it's not a bad idea to be aware of it. In the meantime, I hope you guys study well, you keep well, and make sure you are tagging your friends and sharing this video in other groups. Row out.